So we're going to help you guys become more familiar with the EV3 programming interface and also teach you how to make your robot more reliable and efficient. So basically, just as an overview, in the robot game, you have 2.5 minutes, and which is a total of 150 seconds to complete the tasks on the field. And in order to complete these tasks, you have to create an autonomous robot that's both reliable and efficient. So today we're going to be using a standard robot, which you can see here, just because it's the most simple robot that everyone has probably. And we'll probably give you a basic overview of the standard blocks of EV3 LEGO Labs, and also how to create your own custom blocks to make coding easier. And then we're gonna complete some missions, like the bench mission, the slide mission, and a few other ones. And we hope that by the end of this session, if you have your robot and your computer, you could try to complete at least one of the missions. Yeah. And if you don't have your robot or your laptop, then you can take screenshots of the code or just look at the recording of the session later if you want to use the same code. So first, we're going to make like some basic blocks, and I hope is everyone like familiar with like these basic blocks in EV3? So here we have a few tabs. If you hover over it, they'll basically tell you what they are. Like this one, we'll probably use the most because it's the motion tab, action tab or motion, and it's basically where you can get your motors to move. So this is one of the most basic blocks. It's for a large motor, and on the standard robot, it's the ones that are in charge of the wheels. And here you can specify if you want to use rotations, degrees, or seconds. So for seconds, you're going to be turning the motor on for a number of seconds. For degrees, it's a certain number of degrees. And for rotations, one entire wheel turn is one rotation, and you can have like half a rotation or things like that. So here's the speed, the rotations or degrees or seconds in your case, and also the port. So on your robot, you will see that your motor is plugged into a specific port. Yeah, so you'll have to see which port it is plugged into. For the motors, it's A, B, C, or D, and it's on your board. Yeah. So that's basically how these blocks work for the action. Okay. Next, there are the flow control. This is in charge of the logic. Like this is a wait block. If you attach it to your program like this, then it will first turn on the motor for one rotation, and then it will wait until a certain condition is met. The most commonly used one is the time indicator, which is basically just waiting for a number of seconds. You can also wait for quite a lot of other things, like for someone to press a brick button. And yeah, you guys can probably experiment with things like that. There's also sensors. We won't be getting into too much of it. Today we will only be using the color sensor. So here on our robot that we're going to use today, it's a standard robot connected to also with a color sensor. But there's also instructions on how to go there. Yeah. Then the red tab, there's the data operations, which has variables and basically also logic and also math. So if you're going to do any calculations in your code, like add a variable or subtract a number from it, then you'll be using these blocks. Okay. And to delete your blocks, you can drag them back to where they came from, or just press the delete button on your keyboard. We won't be using the advanced because, like, for making your robot reliable, there isn't that much need for it. It's just more functions. Also, for the last tab, there aren't any blocks in it right now because we haven't made any custom session. We will be going over how to make your own my block, and then after that, you'll basically have like my blocks that look like the standard EV3 blocks that you can drag in and use. So it's basically a chunk of code that you can use again and again without copy and pasting. Okay. And for like these standard blocks, you guys can type it in the chat or just unmute yourself.
Well, maybe they just don't want to talk. I don't know.
Okay. Then I guess you guys are good with those blocks?
Yeah.
Okay. So, well, you should get into a habit of saving your program first. It's just Control S. And if you're following along right now, you can just name your project like something like. Okay. And then if you have your robot, you can turn it on now. You can turn it on by pressing the middle button on the brick. This button, the gray one. And then after that, we'll be connecting to the robot using Bluetooth. Yeah, I'll wait for that to turn. So first, we'll probably be constructing a short program just to get the robot moving, so that you guys understand how to use them. So when it turns on, the screen will look like this. I'm not sure if you guys can see that, but you have to go to the third tab, which is the one with all the squares, and you have to turn on the Bluetooth. Yeah, in order to connect. Or if you guys want to use a cable, you can also plug it into your computer.
Talk a bit louder.
Yeah. Okay. Here we'll be connecting to the robot named EV3. You can find the name of your robot here. So when your screen looks like this in the bottom right corner, then you know that your robot is connected and you can upload code to it. Okay. So to make your robot go forward, you can use the move steering block or the move tank block. We'll be using the move steering for now. The ports of the wheels of the robot are plugged into B and C, which are the standard ones. And this is the direction that your robot will go. This is the speed it will go in, and this is the number of rotations that the robot will make. So if I run this right now, let's see. Okay. Here you can press download and run. And as you can see, my robot is here. And it will just go forwards for one rotation. Yeah. So that is like the basics of how to get your robot moving. We'll just try to complete a mission. First, the robot will be going forward, and the mission we're going to do is the slide mission right now. Okay. Well, the slide mission is the mission here with the figures, and this is the mat if you haven't seen it yet. And you can go online to check out more about that. So yeah, and you guys see the robot here, right? The robot will start in this area, which is the base, and you guys have to find a good alignment spot to start the robot every time. This is really important because where the robot starts running its program has to be consistent every time in order for the code to be consistent. Yeah. So in this case, the robot is aligned like with the logo, with the first logo, because there's a box around it. So we can basically make an estimate of how long it's going to go until it reaches the slide mission. So you can also make a better estimate with the with the stick on the wheel. So one rotation is that much. So you can basically run your robot through and see how many rotations it takes to get all the way to the slide. So here it's going to take about 2.5. So we're going to try that first. It's still going forward, and we'll change the number of rotations to 2.5. And we'll also reduce the speed so that it's a little bit slow. Okay. So after aligning, you can find your program on the robot. Yeah. So yeah, that's about right. And the robot is now here, which is right in front of the slide. And so if you can see here, this is the robot and the slide mission. So how we're going to get the figure, which is on top of the slide, to fall off is that we're going to move the robot arm down. We're going to move the arm down so that it basically swings it and it will fall down. And we don't want to break the model, but that wasn't buttoned properly. So that also stresses the importance of how you should check the mission models at the beginning of your match, just in case one of the Velcro at the bottom of the mission wasn't stuck on properly. Here's a symbol for the medium motor here, so we'll grab that one. It is connected to port A, so make sure that's right. And for this one, we'll do it by degrees because for the arm, it's easier to measure it in degrees this way. And also something else we need to do is make sure that the way the arm is going is correct. So if this is 0, when it's going down, it's negative. So since we want it to go down, we want to put in a negative power in this block. So instead of 50, we'll give something like negative 100. This is because we want the arm to go down really fast in order for the mission model here to go down. For this one, we'll have to experiment with the degrees, or you can just look at this box here. So in this box, you will see the degree reading of your motor. So as I am moving the arm, the reading changes. We want it to go all the way down. So when it's all the way down like this, the degree is about negative 150. So, because you want it. And if you select this block alone and press the run selected, it's only going to run that block. Here you can see that it goes down. Yeah. So now when we run both of the blocks together, it's probably going to do 7. Yeah. And as you can see, it's quite a simple code, but I mean, simpler is always better than having really complicated ways to do a mission. And okay, yeah. This is a robot. Make sure you align it the same way every time. Okay. Well, see, then now we have the problem of how the model doesn't go down on the first try. So we might have to add an additional code of the robot going backwards and hitting the mission again to make the slide, to make the figure go off. Well, first we're gonna try that again so you guys can see it properly. Okay, so if you can see it here, the slide figure fell off. And now since it's not in base yet, we'll have to make the robot go backwards while carrying the mission model with to get some extra. Well, this is basically the same as going forwards, and since we know that it's already 2.5 rotations there, we'll also be going 2.5 rotations back. We'll make the speed a little bit bigger so that it can come back faster, since like precision isn't really an important factor in this case, because all the robot has to do is just come back to the base and then we can grab it and then get it ready for the next. Change it to negative baby or backwards. Okay, so now there's another problem. The figure came off the slide and it's here, if you guys can see it, but it's not in the arms of the robot because it fell after the robot already started moving back. So now we're going to use a block from the flow control tab, and then we're going to make it wait 1 second before it starts going back. So in this case, it wasn't reset in the same position, so it wasn't consistent. And now we'll run it again from the same position. Okay. Okay, so then that worked, and yeah. So then now we can, if we just run this on the standard robot, then we already got some points from completing the slide mission.
So hello everyone, now I will be taking over. So you might have noticed that going forward wasn't the most reliable. So far we're using how many rotations. So we're approximating how many rotations it takes to get from here all the way to there. So in order to fix this, what if we could have a solution where we could turn the wheel to go by centimeters instead. All right, so we're going to do just that. So then right now what we're going to do, we're going to make a new program here. You guys can see my screen, right? Just making sure. All right, good. All right, so now, all right, so what we're going to do is that in order to go, so we're going to have a loop. So the reason why we're going to have a loop here is that we're going to make this program run continuously until the wheels have reached a certain amount of distance. So hold on, hold on. So then what we're going to do here is that we're going to put in our motor block here first. All right. So first of all, what we're going to do is that we're going to turn this motor on. All right. So then now we have like a, so then now if we run this right now, it's going to run continuously. So then if we run it, so then it'll run infinitely. All right. So in order to, so what we need to do now is that, so in the yellow tab, as we mentioned earlier, this is where we have all the sensors. So this is where we can get the motor rotation. So if I go to, we go back to here, integrated camera. All right, so if you see over here on our wheels, you can see like there's a little pick over here, right? So what we want to do is that we want to go forward for a set amount of like rotations until it like reaches like a certain distance. So in order to do this, we need to use some math here. So then if we, so we're going to choose one of the motors. So let's just say motor B. So that's the left motor right over here. So what we need to do is that we get a math block and we need to run a calculation. So what we're going to do is that we need to get the, we're going to do 360 divided by, and then divided by the diameter of this wheel. So in order to get the, so chances are you're probably using the same robot as we are. So then you'll probably get the same like dimensions as I do. So we need to get the circumference of the wheel. So we're going to do 5.6 multiplied by 3.14 because that is how you get the circumference of the wheel. And then we have to multiply by 8. So if you see on the block over here, like if you see where my cursor is, you can see there's there's 4 input values you can put in. So then, so what this A refers to is that if we is like how many centimeters you want to go. So then, actually, hold on, we don't need this. Sorry. So what we need to do is that we can put in a value here, like say, let's put 10. All right. Then after that, what we have to do is that instead of this being unlimited, we have to go to motor rotation and then degrees. So then right now, what this is right over here, so this is like how many degrees it goes for 1 centimeter. Should have mentioned that earlier. So what we need to do is that we need to change this to greater than or equal to, and we plug this in over here. Make sure you change this value as well. So then after that, if we did it correctly, hold on, then this should work quite well. So if we run this right now, so as you can see, I don't know if you can see it very clearly, but the robot went for its 10 centimeters. All right. So then, all right. So this is probably, so then what we need to do next is that we need to reset the motor rotation first, so that it always goes to we always measure at 0. And then once we're done, hold on. Once we're done that, we need to stop the motors because otherwise it will just glide. All right, so this was probably this is probably one of like the more trickier parts of this seminar. So if you have any questions or if you're confused or if you don't understand, please say so right now, then I can address your like concerns. Do you guys have any like questions on this? Probably do. Like, do you guys understand?
You guys can unmute yourself and ask questions as well.
All right, so I don't think anyone has any questions. So I think that everyone should understand this. So even if you still don't understand the formula, this is the formula that you need. So now what we're going to do is that we're going to turn, so we don't want to, every time we want to go forward, we don't want to keep rewriting this all the time. So what we're going to do is that, so you know how in the beginning of the seminar, we mentioned this area called My Blocks. So now we're going to use that. So we need to select all of this. And then we have to right click, and so no, not right click. We have to go to Tools and go to My Block Builder. All right, are you all with me? So then, now what you're gonna do is hold on, chat. Okay, good. All right, then what you're gonna do is that we need to put in a name. So we're gonna name this forward. All right, then we're going to do this. We're gonna put a few parameters. So now what these parameters are is that, so if we look down here, as you can see on the motor block, there are two parameters. There's the left wheel and the right wheel. So then here we want to have those same parameters, but we don't need the different wheels this time. So we're going to put this one parameter. So we're going to go to parameter setup. So here we're going to name it speed. All right. Then this data type is going to be number. We don't need to change that. We can have a default value of 10. You don't need to like set this one, but if you want to, actually not 10, 25. Like, so you don't need to set this like default value yourself because we can always modify it later. But if you want to go ahead, and here we can just put a horizontal slider because usually the speed has that. So we're gonna go to parameter icons, so it looks better and it's more clear to us, and we will just put this speed icon. All right, next we have a second parameter that we need, and this is the amount of centimeters we want to go forward. So we have our let's select the centimeter icon, or any icon you want, and we can put distance. We can put a default value of 10, and then I think that's it. All right, so is everyone with me? Just making sure. All right. All right, good. So now we're going to click finish. And then you'll see we are put into another area. So what we need to do now is that we need to put this speed into here. And then we need to put the distance, as we put the distance centimeters, as we know it was from here. So we need to plug that into here. This is my favorite number 10. It's kind of close. It's pretty good. I just usually just put 10. Like, I'm just used to it. I don't know. All right, so is everyone with me? Have you guys, if you guys are following along, have you guys put like the input stuff in? All right. All right, so so I think everyone should be fine. So what you have to do is that you have to like, so then now is a good time to like save it, because if you don't save it, sometimes it can corrupt, the project can corrupt, and then it's not going to go very well. So now we have our forward block here. And then now say we want to put like 20. And then if we run this, like that. And then now the robot has ran 20 centimeters. So if you're running this, so if you're like doing this on the side, right now test your robot to go a set amount of distance and see if it actually goes that amount of distance. Now we are going to do we're going to do another mission. So this one, we're going to do this one, which is the basketball mission. So what we have to do, what we're planning to do is that we want to align the robot, and then we want to go forwards. Then we want to go there. We want to lower this arm. We're going to go forwards, and we want to raise the arm up a bit. And then we're going to go back. All right, please understand what we're trying to do here. All right, good. So now, all right, so we are going to, hold on, let me change my camera real quick. So the very first thing we have to do is that we need to find an alignment position. All right, so right now, if you can see kind of here, it's very important that you align against the wall, because then you can ensure that your robot is going straight. So you also have to make sure that everything is within. So now you have to make sure everything is within the base. So it's not that clear over here, but we're aligning with this. There's a line over here that we're using, putting on the wheel next to it so that we're aligning against it. So then what we're gonna do is that, so in order to test the position, you can like go forwards, see if that is going to like make it. So it's a little bit to the south, so we can like. Yeah, I think that's all right. So, all right. So now what we're going to do is that we're going to measure the distance from here, from the basket, from here, from our starting position to the basketball area. So that if I measure 45, 90, 89, 88, 87, 86, 85. Shoot. $45. $32, 45 plus 4, 33. All right, so measured it, and it's about 78 centimeters. So if we put that as 78, and then we can like test that out. So then we run it here. All right. All right, so 78 looks pretty close. So now what you might have noticed is now the arm is like up. So what do we do about that? So right now, so if you look down in over here where my cursor is, you can see the values of each motor. So then what we're most interested in is this medium motor. This is the one that like uses, this is the one that turns the arm like that. All right. So then right now at its highest position, it is at a rotation of 3. Now, okay. So then it's at a rotation of 0. So it's like, so this is its reset position. So then what we want to do is that we want to find a disc. So we want to find the rotation that goes under the basketball. So then if we go forward like this, then I found a value that is negative 145. So what we need to do is that we need to change that value. So we need to also, so then we want to have a move arm block. We want to make it slower because otherwise it would be way too fast. I want to put it in degrees. I want to put it to negative 145. All right, so then now so then what you can do in EV3 is you can like run it, you can run this block and that one at the same time. So you see like this cord over here, it's like running here and there at the same time. So then these 2 blocks will run at the same time. So if I do a quick demonstration here, then it will run, the robot will run. And then we need to go a bit more forwards. So we'll just put that to 80 because it's a bit off from the basketball. Then here, what we can do, you guys go there, then we could raise the arm. Hold on. You can raise the arm there and to that height, which is around negative 70. I think that should be enough. And then we can lower it and then we can go backwards. All right, so we're going to code that. So then now we're going to bring that there. We're gonna put it at, we're gonna put it at 20. We put on 4 degrees, and then we're going to put it at, we mentioned 70, right? Yeah, 70. So now we're, actually this should be like 79. All right, so then now once we've done that, then we could go, hold on, yeah, we can go backwards. We can go backwards, -25, and 79. We can go backward. We can go all the way back to base. All right, so then now, once you've done that, we can run this. Oh, shoot. Shoot. There we go. There we go. All right, so now as you can see, using this code, we can finish the basketball task. So then, all right, so then for those of you that are following along, if you're following along, then you probably should have got like the same result. If you didn't, you could like, so you can tell me if you got the same result or like what happened. And yeah, I think we're like almost out of time, so I think we could like kind of wrap up right now. You guys have any further questions, feel free to ask us right now. Come on. Oh, there's a chat question, hold on. Do we need to download it, like the thing you're using?
Yeah, it's from the internet, so if you search up LEGO Mindstorms Education, then you can download it and you'll probably find us. Right now we're using the teacher edition, which has some extra features, so you'll probably also want to find that one. So you can see the name of what we're using at the top here.
It's over there. So you can just search up LEGO Mindstorms Education EV3 Teacher Edition.
Yeah, we recommend using the teacher edition.
Yeah, make sure it's like the PC version. I think there are some versions on the Microsoft Store and on the mobile app store. Those ones are very limited in features. Don't do that. Where do we get the robot? So to get this robot, if your team has bought like a education kit,
it's like a standard EV3 kit. Basically, it's like a big black box, and in it there's actually instructions for a standard robot.
Yeah, for this exact robot.
Yeah.
I think it should look something like, can I go here?
Yeah.
All right. LEGO EV3 education set.
Yeah.
And it should look something like, yeah, something like that. Well, not all of these boxes, but yeah, something similar to this. Like just the box.
One box is enough to make one of these robots and like make some attachments for it.
Mm-hmm. All right, let me address any. There's some other questions. Hold on, let me get to them. Chat. You have to download the old one. Is there a new one?
Okay, so there is a new one that is like more kind of like Scratch. Mm-hmm. It's like a little bit simpler, but
it has a lot less features.
Yeah, there's some less features because like not all of the things that this one has are part of it. Well, yeah, EV3 Classroom. I think EV3
Classroom should be fine. Yeah.
The basic concepts are the same, just like maybe some of the features aren't in there yet.
We have a class that is using Scratch. So the one we mentioned earlier, we didn't mean like it's actually Scratch, but like it's like a lot.
Like what the new class.
Mm-hmm. Yeah, so if you go on the App Store and then you can download like the EV3 app, then that's what we are like talking about. And that one is a lot simpler. Hold on, what's EV3 Classroom?
Okay. Thanks, guys. So I think that's pretty much all we really have time for right now. If participants have questions for you later, is there an email that they can contact you at?
We're all part of a robotics school called Dr. X Academy, and there's an email there. So if you guys want to like basically contact us there, we're always available here. Yeah.
Okay.